G'day guys, it's Dan here from Reptile Encounters. Thanks so much for joining us again today. It's always great to see you all popping up and saying g'day. While I've got you, we're waiting for some more people to join in. A few little notes. Number one, we're now selling our wild live streams for schools and kinders, so we can still come and give you the same great incursions, the same amazing animals beamed straight to your kids. So if you are interested, please get in contact with us. Make sure you subscribe to us on YouTube so you're keeping up to date with all the amazing content that we're going to start uploading there. And make sure you've got notifications turned on for our live streams and our other posts on Facebook so you don't miss any of the wildlife fun. We're also advertising now our animal sponsorship packages where you can sponsor your favourite animals, make sure they're all getting their favourite treats, and a whole bunch of extra goodies for you as well. Make sure you're saying hi as well as we're waiting for more people to pop up. Anybody said g'day?
Yeah, we've had a few people say hi. Michael said hello, he's watching.
G'day, Michael.
So we've got a few people tuned in, so maybe reintroduce yourself and we'll get started.
All right, well, again, I'm Dan. I am the Senior Executive Wildlife Ambassador for Reptile Encounters, and today we're touching on one of my favourite shows. This is Evolution and Genetics, one of our secondary school shows. And in this show, what we look at is DNA and genetics, but as a kind of vector for evolution, the way that natural selection works. So we know that everybody, and that includes animals, are all a little bit different. And in some situations, being a little bit different is better. In some situations, it's not a little bit better. And this is how we end up with survival of the fittest. Nature is brutal, and you got to be the fittest to survive. And so these animals have evolved over millions and millions of years to be the animals they are today and to be the best they can be to survive and thrive in their ecological niche. Now, the first animal we're going to meet today, one of my absolute favourites, this is Dave. Dave is unfortunately a marsupial that not many people have heard of, which I think is not very fair at all because he's awesome. Here's Dave here. There we go, buddy. Dave is called a long-nosed potteroo. He's not a kangaroo, he's not a wallaroo, he's a wattaroo, a potteroo. Now, these guys are found in the forests of eastern and southeastern Australia and in Tasmania as well. Losing my voice already, that's not a good sign. And they are nocturnal. They'll come out at night to go looking in the undergrowth on the forest floor for fruits, for tubers, and for their favourite foods, mushrooms. They absolutely love eating mushrooms. And that big long nose makes them one of the only mammals in the world specially designed to dig up truffles, their favourite food. And where they live in the wild, you don't often see them. What you do find is the tracks they leave in the undergrowth and the holes they leave in the ground where they shove that mouth and that big long snout down to grab the underground fruiting bodies of the mushrooms and fungi that they love to eat. Now, Australia, I'm going to have a drink for a second because my voice decided to go nuts on me.
All good. While you're doing that, we've had some hellos. We've had hello from Lulu, Connor, Helena, and Cheryl.
Oh, Lulu, Connor, Helena, and Cheryl, hello.
Yes.
There we go. Now, Australia is famous for our marsupials. We've got a greater variety of marsupials than anywhere else on the planet. With the exception of some parts of Southeast Asia and South America, most other parts of the planet don't even have marsupials. They used to be a far more predominant group of mammals, but nowadays they're not. In Australia, the oldest marsupials that we have tend to look kind of like Dave. In fact, what we think originally happened was there was one or two little species of marsupial that would have looked like rat kangaroos. And there's actually a species up in the rainforests of northern Queensland called a musky rat kangaroo that's even more primitive than these guys. Long-nosed potteroos have basically not changed in about 10 million years. And the musky rat kangaroo is even older. It hasn't even evolved the ability to hop yet. Even though it is a macropod, it is related to kangaroos and wallabies and potteroos. So what we think's happened is these little ancient marsupials, when Australia has separated, and a lot of the animals that we find overseas, like hooved animals or cats and dogs and bears and weasels and things, simply didn't exist here. These little rat kangaroos have spread into all the different habitats, all the different ecosystems, and all of the different niches. And in those new niches that they've found, they have evolved features to suit their newfound lifestyle. Some of the ones that stayed in the forest stayed nice and small, so it's easy to hide. They're solitary. Living in big groups when you're trying to hide isn't usually very good. And so that's how we got things like potoroos, which suit that lifestyle perfectly. Some, on the other hand, would have gone out to the grasslands and the plains, where being small isn't always very helpful. There's not always a lot of cover. Being big makes it harder for predators to eat you. And living in groups means there's more eyes looking out. That's how we ended up with things like kangaroos. And we've got possums and koalas and wombats and all the little carnivores like the dunarts that you've met. And you know, some went up the trees like possums, some went up the trees a little bit later like tree kangaroos. And we've got all this amazing diversity of marsupials, but it's all come from one very similar ancestor. We call this divergent evolution, where you've got one ancestral animal that shoots out in all these different directions and takes on all these different body shapes and lifestyles and diets and all that sort of thing. That's divergent evolution. Now, marsupials are obviously a fantastic example of this, but we do see it in other parts of the world. Darwin's finches, the little finches from the Galapagos that first inspired the ideas of natural selection and evolution in one of the most famous biologists of all time. Very, very similar birds that were all very closely related, but their beaks had started to change shape. Some were bigger and thicker for crunching on really big seeds. Some were long and skinny for picking up little ones or for grabbing little grubs from in between bits of bark. That kind of selection, depending on the island they were on, changed the shapes of their beak. And so even though they were closely related and had a lot of features in common, they were starting to change. And again, this is divergent evolution in action. Now, Dave's got the wriggles at the moment. Where you going, bud? He's keen for his daily piece of banana, I think. So I'm going to pop him back. And we're going to meet an animal that is an example of the complete opposite of divergent evolution. This next animal is a favourite of mine. There's a big picture of her on the side of my car, actually. We'll get her out. Even for all these things, she's still usually kind of grumpy with me first thing in the morning. Is this the world's largest drink bottle of water? Now, this is Harriet. Where are you going? Excuse me.
Hello.
Oh, you took your Jessie off. Harriet knows how to take off her Jessies, unfortunately. Can you come here? We'll go to the ground and we'll try this again. Geez, you're cheeky. Out of all the barn owls that I've ever worked with, I've never met one that actually knows how to take off her leash as well. She's a smart one, this one. Harriet is a barn owl, after all that excitement. Now you're standing still. Barn owls are one of the most widespread and successful vertebrates on the planet. They are found on every continent except for Antarctica because it's a bit cold, and that's because their favourite food is found on every continent except for Antarctica. They love eating mice. Mice and other small mouse-sized mammals. And in Australia, we have a lot of mouse-sized mammals. Yes, we have the house mice that we might find running around our kitchens every once in a while, but we've also got hopping mice and other native mice. We've got things like dunarts and antechinus, which will all be on the diet of a barn owl as well. Now, barn owls are a raptor. Raptors catch their food with their feet. And if you have a look, she has got big, sharp talons. She has got very long, sharp talons. That's why I got to wear this gauntlet, this special glove, to make sure that she doesn't put those claws into my hand if she gets a bit of a fright. Now, owls are not the only raptors. We have eagles and hawks and falcons and harriers and kites and all these other birds as well that catch their food with their feet. Excuse me. I'll turn you back on me. She's grumpy. Now, owls are one group, and all those other ones, eagles and hawks and falcons, are another group of raptors. The two groups are actually not related to each other. They have evolved the ability to catch their food with their feet completely separately. Eagles and hawks and falcons and all that, they have got an ancestor that they share with things like herons and storks and cranes. And if you've ever seen a heron flying overhead, sometimes you'll see the big long wings with those kind of fingered feathers off the end, kind of like an eagle. And you can kind of see that there might be a common ancestor there. Owls have a common ancestor with hummingbirds, which are nothing alike. Tiny little buzzy things that drink nectar all day. Evolution does some really, really weird things. Throws things out in every direction. If it works, it sticks. If it doesn't work, the animal goes extinct. It's kind of brutal, but again, that's natural selection. Evolving the same feature to do the same job, even though the animals are not related, is called, can you sit still? is called convergent evolution. It's the opposite of divergent evolution. Instead of one species evolving in different directions, it's completely unrelated animals evolving similar features. Owls and the other raptors are a great example of this, but even things like possums and monkeys have got a lot of body features in common. Prehensile tails, the way they climb, even though one's a marsupial and one's a placental mammal. It can be even more extreme than that. Dolphins and sharks have got a lot of features in common in their body, with the placement of their fins, the way that they move, the streamlined bodies for moving fast. One's a mammal, one's a fish. And they've got all these things in common because it helps them survive and thrive in their niche to the best of their ability. Now you're going to sit still. Now I've got to put you back. That's okay. She wants to be back in bed, and that's totally fine. She is an owl. She is supposed to be nocturnal. Now, you jump back in here, please. Thank you. Now she does what she's told. It's her favourite part of the show, I think. And lastly, we're going to meet some reptiles. I've actually got more than one. They are the same species, but they're not going to look exactly the same. We're going to start with my mate Hoover, who spends lots of time riding around on my shoulder. Here you go. Hoover is called a central bearded dragon. Now, this is the most commonly kept pet reptile on the planet. They are fantastic pets. They seem to genuinely, you could almost say, enjoy spending time with their owners, sitting on shoulders. Anywhere they can sit and sticky beak, they're usually pretty happy. And they do that in the wild as well. He will sit in the wild, a wild bearded dragon, on a fence post, oh, got some hair on you, or a stump, or even a branch, pretty much like that, all day, looking around with his big eyes. They've got fantastic eyesight, and if he sees anything moving, they love eating little invertebrates and things, or even some flowers or leaves, he can go down from his favourite perch, have something to eat, come back. And they will spend all their time sitting in the sun, flattened out, soaking up all those rays, showing off all those big spikes just in case any predators get any funny ideas. Now, one of the reasons these guys are such popular pets is because they come in so many different colours. Even in the wild, they can be red, they can be yellow, with a bit of white through them, like Hoover is. Lots and lots of different colours and patterns, and people like that. In the wild, they've evolved these different colours and patterns depending on where they live. It's all camouflage. If they're living on red sand, they're not going to be yellow and white. They're going to be a more reddish-brown colour. If they're living in more white sand areas, yeah, sure, they'll be more this colour because it helps them to survive. In captivity, they don't, or they shouldn't, have any pressure from predators. There shouldn't be anything trying to eat them because if we're looking after them properly, they should be totally safe in their enclosure. But people breed animals for different reasons. We breed animals to suit the things that we want them for. This isn't natural selection. This is called artificial selection. And we have been doing this for a very, very long time. Selective breeding is how we've ended up with things like the sheep and cows and horses that we have in livestock and agriculture today. Once upon a time, chickens didn't look the way chickens currently look. The red jungle fowl from Southeast Asia was kind of like a mini chicken. But we've either bred them to grow up faster, so we can use them for their meat, or to start laying their eggs quicker and lay more eggs over a bigger chunk of their life, so we can use them for the egg industry. This isn't something they're going to be selected for in the wild. This is something that we've used them for. It's even how we've ended up with most of our dog breeds. Most dog breeds have come from wolves. Think of something big and majestic like a grey wolf from the Northern Hemisphere, and then you see something like a husky, and you go, okay, I see the resemblance. And then you see a German Shepherd, you go, okay, it's still kind of there. And then you get a pug. We don't always make the best decisions when we breed some of these animals. Now, because keeping reptiles has become so popular over the last few decades, we've started to breed some of these animals for colours and patterns as well. Overseas, it's been done a lot more, but in Australia, far more recently, with the more commonly kept species like bearded dragons and carpet pythons, and more recently, blue tongues. We call them morphs, and they come in all these colours and patterns, and we breed them to look as pretty as possible, because for breeders, in a lot of instances, those more beautiful animals look a lot better and are worth a lot more money. Now, personally, I don't think it ever looks any better than it's supposed to look in the wild. Nature makes them as beautiful as possible. But that doesn't stop people from playing God every once in a while. My next bearded dragon here is another lovely little girl. She looks a bit different. Her name's Frankie. There we go. This is Frankie. And Frankie is what we call a high white leatherback bearded dragon. So she's still a central bearded dragon. She is exactly the same species as Hoover. They are male and female. If we gave them the chance and they loved each other very much, we could probably end up with a few more bearded dragons. But you can see that she looks quite different. Number one, her colours are a lot brighter. She's much more of a bright white colour, especially when she's warmed up. She really colours up. And her spikes, as you can see, are a lot more reduced, especially on her back here. The scales are smoother and rounder. I wish you could touch it, but it's not touch-o-vision, it's television. Here on Hoover, they're a lot spikier. Leatherback has been bred into them because when the scales are smaller, the colours stand out more. Now, she still functions pretty much exactly the same as a regular bearded dragon. She's still got scales, but there's another morph, the next step from that, which is something called silkback. And in silkback bearded dragons, they pretty much breed the scales completely off them. This means the colours are incredibly intense. It basically looks like someone's coloured them in with textures. But they don't have scales anymore. They evolved scales for a reason. It's protection. And all of a sudden, these silkback bearded dragons can develop issues with their skin just from sitting in the sun or under their UV globes in their enclosure. This is an animal that literally sits in the sun, in the wild, all day. And we've bred them so sitting in the sun doesn't actually work very well for them. Not only that, but there's a problem when they breed. See, when lizards breed, again, when they love each other very much, the male will grab onto the female's neck. If she's got scales there, she's got some protection. If there's no scales, the male can rip her neck up really badly. She can end up bleeding and she can end up in serious trouble. So in order to breed them to be prettier and worth more money, we've ended up breeding them so they can't sit in the sun and they can barely mate with each other. There are downsides to artificial selection, and sometimes when we're so focused on one feature that we're trying to breed for, we can end up with all these other genetic issues coming through. Again, pugs are a great example. Pugs can't breathe properly. Their snout has been shrunk in to make them look cute and bug-eyed and things like that, but the nasal passage isn't straight. It ends up being curved up, and on hot days, they can't breathe. And a lot of pugs have to have surgery to have their palate pushed up so their windpipe actually works properly. When we focus on that one feature, if we're not responsible with the way that we breed these animals through artificial selection and selective breeding, we can cause a lot of issues, and this can end up with our animals in pain. Things like American bulldogs can't even breed with each other properly anymore because of their weird proportions. So we have to be responsible with the way that we breed these animals. Yeah, it might have brighter colours, but if the animal's going to suffer, it's not really ethical to breed it. And again, perfectly normal central bearded dragon is still an absolutely beautiful animal and a fantastic pet. There's no need to muck with something that nature has already perfected. Now that's all the animals I've got for your snippet of evolution and genetics. If you want to hear more, you're going to have to get us in your classroom, either in person or via the live streams during the current crazy health times. So I'm going to put these two down, or I'll put one down, I'll keep Hoover out with me. And if you guys have got any questions, now's the time to ask.
We might have a little lag, so I'm going to go through.
Okay.
We've got a few people laughing because Labradoodles.
Yeah, poodles will breed with anything.
Yep, and we've got, say, a few things that people are really excited to learn. So hummingbirds, the fact about hummingbirds is really interesting.
Yeah, it's weird, isn't it?
Yeah.
Evolution leads us to some weird things. I mean, the ancestor of whales originally looked like a dog. They used to walk along the beach. Evolution throws things in any direction possible, and the stuff that works and is all in those genetics. The little strands of DNA in every cell in your body, every cell in his body, and everything else's is what gets passed on to the next generation. It's what leads to natural selection and evolution working the way that it does. Those tiny little bits of code in your cells lead to all the animals that we have, and all of us, and all of our differences and all of our similarities, and what works and what doesn't work in times of trouble as well.
We have a few questions about bearded dragons.
Yep.
The first one is, how fast can they run?
They're pretty quick. So similar to a frill-necked lizard, when they run, if they're really panicking, they can get up on their back legs. They can't get all the way up like a frilly. Frillies are really good at that, but most of the way up, and run bipedally, so on their back legs. And frill-necks and bearded dragons can both get to about 17 kilometers an hour. Frill-necks got much longer, more powerful legs than a central beardy. Eastern bearded dragons, though, do have longer legs as well, so they can probably get a bit faster than a central, but 15 to 17 kilometers an hour in short bursts. Running on your back legs is tough. They don't save much energy doing it, so they can only do it in very short bursts. But even on all fours, they run real quick.
The other question we have about bearded dragons is, are they monogamous?
No, not at all. Out in the deserts where they live, they will go for whoever's around. The only reptile that we found is monogamous is shinglebacks, stumpy-tailed lizards, my favourites. They are the only reptile that we know is monogamous almost all the time. There are some other species where monogamy does pop up, things like our Cunningham skinks that we get around Melbourne. In the wild, if given the choice, will live in small family groups and they won't really breed outside of those little groups. But shinglebacks are the only ones that really seem to be properly monogamous. Year to year, even over the course of a season, these guys will breed with different partners. A female central bearded dragon can have 30, 40 eggs in a clutch. There are records of a lot more than that, but they're a little bit sketchy. But yeah, look, 20 to 30 eggs definitely happens quite often, and she can do that 3 or 4 times over a breeding season, and it doesn't have to be with the same male.
Anton is asking, can you get Hoover to wave on cue?
Can I get him to wave on cue? Yeah, look. He's waving. That's not my... He's moving my finger.
Maybe you can talk a little bit about them waving.
Yeah, so dragons will use sign language to communicate with each other. Lots of our dragon species talk to each other like this. If a male who's in charge of his little territory spies another male getting a bit too close, he'll start bobbing his head like this. And that means, oi, what are you doing? And if the other male slowly waves his arm and kind of slouches down a little bit, it means I'm just passing through, you're the boss, it's all good, I don't want to have a fight. If he starts bobbing his head, it means, what? I can take you, and they can end up beating the snot out of each other. They will get into physical altercations, but they puff themselves up, puff out their beard, the beard can go black, make them look really big and scary, everything they can to say, I'm bigger and tougher than you, don't you try and mess with me, before they actually get into a physical altercation. Things like our smaller dragons that you would have seen in the live stream earlier this week will whip their tails, do little push-ups, flash their colours. They will all use different visual cues to communicate with each other. So they don't really have to get into a physical fight, and no one has to get hurt, but they can still get the message. Doesn't always get across though.
Maybe we'll end off with one last question from Jordan, which is, what is the lifespan of a bearded dragon?
So in captivity, you'd be looking at 13 to 15 years on average. I've heard of them getting up over 17 years old. They don't quite live as long as things like blue tongues and shinglebacks that can get into their 30s or 40s. Dragons tend to have a bit more of a fast metabolism. Everything happens a little bit quicker for them. But yeah, 15 years for a bearded dragon, if it's cared for correctly and its enclosure's fantastic and it's getting fed the right stuff, is definitely something that can happen.
Awesome. I think we'll end there. Thanks so much, Dan.
Beautiful. Thanks so much for tuning into our live streams again. Guys, we're going to be back at 2 o'clock this afternoon for something a little bit special. We're going to be doing Wildlife Chef, where some of us compete to cook the best meals for our animals. It's going to be a lot of fun. Tune in. Make sure that you've got notifications on for our live streams. Make sure you've subscribed to our YouTube. And teachers and carers, if you are interested in something for the kids, get in contact, find out about our wildlife streams, where our wildlife comes directly to you through your computer. I'll see you next time.